Hi, everybody. Mark here, Director of Education at ED Academics. And today I wanted to go over another essential math concept, perfect squares. What is a perfect square? Let's find out. So let's start with this word, square. We know what a square is. A square is a shape. Okay. Most people, most young learners, we grasp this. What is a square? A square is a shape that has the same side length all the way around. So here, for example, we have a square that we call a 3 by 3 square. A 3 by 3 square means it has a side length of 3 all the way around. Okay? How many boxes are in this square? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we say that 3 times 3 is 9. That's also what's called the area of the square. The area of any square is its length times its width, okay? In this case, the length and the width are the same thing, okay? So when we want to multiply two numbers together, mathematicians, they kind of have a shorthand way of writing this. They'll write this as 3 to the second power, 3 to the exponent of 2, 3 squared. The reason why we call this exponent the exponent of 2 squaring is because it tells us the area of a square with side length of 3. 3 squared is 9. Oh, that was a little bit off. Ooh, all good. We're going to switch it up. 3 squared is 9. So we say 3 squared, 3 to the exponent 2, 3 to the second power is 9. Critically, 3 squared is not 6. That's a common mistake young people make. It's not 3 times 2, it's 3 times 3 twice. Okay, so we have to know what exponents are. So we say 9 is a perfect square because its side lengths of 3 are nice, round, whole numbers that we can count. Okay, now let's think about other squares, other perfect squares. Well, and let's practice our exponents along the way. 2 squared, 2 times 2, 4. 3 squared, as we know here, is 9. 4 squared, 4 times 4, you know that one? 16. 16. 5 squared, not 10. It's not 5 times 2. It's 5 times 5. That's, no, it's not. It's 25. Okay. 6 squared, 6 to the second power, 6 raised to the exponent of 2, 36. 7 squared, 49. 8 squared, Nintendo 64. That was my favorite growing up. You know, with that controller, it was like, it looked like this kind of. Had like the, the C-pad and stuff. That was bad. Anyway, 8 squared, 64. 9 squared, 81. 10 squared, 100. This list goes on and on and on and on. But what we say is that all of these numbers, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, 25 is a perfect square, 36, 49. Why? Because an area of 16 has a side length of 4. An area of 25 has a side length of 5, and so on. Okay, so an important concept in relation to this is what the square root is. Okay, because 25 has a side length of 5, or a square that has an area of 25 has a side length of 5, we say that the square root, which is this symbol, a root or a radical symbol, is 25 square root equals 5. Why? because the square root of 25 is 5. What about 16? We can say the square root of 16 equals 4. Okay? The important thing here to keep in mind is that there's a relationship between squaring and square rooting. The important thing here is to understand that a perfect square is any number that when you take its root, it is a nice, round, counting whole number. Okay. Let's look for an example of what isn't a perfect square then. What do we mean by an imperfect square or a number that's not a perfect square? Here's where it gets a little bit tricky, and here's where it's important to understand how the language, the concepts, the notation, the calculations, the decimals, the symbols, all that stuff goes together. So let's say we want to have a square with an area of 20. I'll draw it here. Okay. 20. What is the side length going to be? What is the root going to be? What is the square root of 20? Well, that's not something we can just know. Well, maybe we know it's going to be between 4 and 5 because 4 squared is 16 and 5 squared is 25. So some number between 4 and 5 has to equal 20. I'm going to use my calculator right here. You can use your iPhone or this one. Okay. I plug in this number. Okay. I do square root. It kind of looks like this. 2, because there's different types of roots. There's square roots, there's cube roots. We do the square root. Okay. There's an X in here on your calculator, but we're just going to plug in that number 20. And the square root of 20 is, ready? 4.472135. No, it keeps going. It goes on and on and on and on. And actually, this number will go on forever. It'll always be changing. We know it exists, but we don't really know what it is. And this concept can be kind of confusing, especially for, let's say, a middle schooler who wants to learn this for the first time. So what mathematicians say is, well, we can't write numbers forever. So we just end up saying that the square root of 20 is roughly 4.47. They're just going to put the root of 20. Root 20. Okay? It's a number that we know exists somewhere between 4 and 5, 4.472, and it goes on and on. So this type of number fluency, this type of understanding, this ability to connect the shapes with the numbers, the calculations, the concepts, the ideas, all of these things are really critical for math. Because if you don't know this stuff well enough to work with it in calculations and computations, it's going to be hard to stay focused and stay on top of math ideas and math concepts. So let's start. Thank you, everybody, for your time. I hope this was very helpful. And thanks for tuning in. Oh, I forgot to do this part. Here we go. As you all know, this is a cube. That's a whole other lesson called cubing. There we go. And then finally, we got to do this guy. Let's do CS, Mark's favorite. Bye, everybody.